Okay, hello everyone. So welcome to lecture 6, which is going to focus on soldering. I hope you guys have had somewhat success in the sensor fusion lab, but I know that from working with you guys, Alexia and I have realized that it's a lot harder this time around. So we completely understand, and that's why we're planning on moving forward with soldering, but you're still going to have the available tools and time to hopefully complete that. And again, make sure you ask us any questions or ask us to run through with you if you're falling behind, which is no problem because a lot of teams often do that around this point. Yeah, but finally, you're going to be able to actually work on parts. So once again, if you haven't done lab safety yet, make sure to do that. But I'm pretty sure almost all of you guys have. If not, you're kind of a criminal. But come in during our lab hours if you want a lot more help. If you think you kind of understand, you can go in anytime that the lab is open. Again, it's 10 a.m. to 6 p.m. on weekdays. Weekends, with exceptions, they're going to be closed. If you don't know where the lab is, just go to this website. This link will show you. And at every time, there should be at least one officer in there, and they will be able to tell you how to get started with soldering. And if you already have some prior knowledge, it'll help you a lot. But we also have a soldering lab coming up from our workshops team. Okay, yeah, so basically our PCBs already arrived and our parts did as well. So we will be giving to those two guys in your respective team boxes. The deposits that you guys put in at the beginning of the year will also be returned for most of you. If you stuck through around to this time, we're pretty much guaranteeing that you'll get it back. But if you guys are kind of struggling, might be a percentage of return, but we will see about that for each case. And just to reiterate, the centrifusion lab is just going to continue. We're not going to have a hard deadline on it because it's been so tough, but you'll definitely need to know that stuff after soldering because that's when we're going to move on to actually programming the quad. All right, so in this lecture, we're just going to be going over soldering basics and the tools that we're going to be using, a couple tips and tricks, and how you can start to actually connect to your PCBs. But just take into consideration that this lecture is not going to tell you all the nitty-gritty details of how to solder. This is just going to tell you what you should do or what we did and some of our experiences. But again, other officers have experience as well, and your best friend is going to be YouTube here because there's a lot of great tutorials. We'll link a couple, but just go search up on your own behalf and you will find a lot of stuff that's going to help you a lot. So make sure just be prepared before entering the lab. Okay, so tools. The tools that we will use, here's a list of them. So we have the soldering iron, solder wick, and sucker. These are the three main ones. Basically, the soldering iron is the metal tip that you're heating up and you're actually holding in your hand. The solder is the stuff that you're melting to make the connections, and then solder wick or a solder sucker is basically what you use to desolder any components. So if you screw up, solder wick can help you get rid of the solder that's already there, and then I'll help you basically undo what you just did. It is a little bit tough to work with though, so again, make sure you watch a tutorial on this stuff. And all of these are provided in our lab. It will be at the very back if you haven't seen it already. There's a bunch of stations there and you'll see it. We also have heat guns and solder paste. If you're not sure where they're located, just ask anyone, they should know. I think it's up in a cabinet above the solder stations. Solder flux, which is optional, just like the heat gun and solder paste. The solder flux is basically, we'll talk a little bit more about it, but it's kind of like this material that just helps the solder do what you want it to. And that's a really non-scientific way of describing it to you, but you'll definitely see what I'm talking about. We should have some available in the lab. And also there's some solder flux on the solder already, just to help it maintain shape and whatever. But basically it helps connect to the metal pads that you want to connect to and not stiffen up too fast. Yeah. But this will be helpful if you ever screw something up, just like the solder wick. Okay, and also, most importantly, that I feel like a lot of people don't emphasize is a multimeter. So there's multimeters in the lab. If you have your own, you can use your own, but it's really, really important for hardware debugging because if anything doesn't work the first time you connect power to it, things can go very south. So make sure you're working incrementally. And what that means is basically you make a connection and you make sure that it's thorough. So you can use a continuity test. If you don't know what that is, go search it up. It's just a function on the multimeter. But apart from that, you can also measure resistance and make sure that certain certain traces aren't connected. So for instance, you don't want your VCC and your ground to be shorted. So you can test for continuity. If there's a beep, it means it's connected, which means you shorted it. And definitely do that before you connect power, because if you do it after you connect power, then you're going to short the whole board. So yeah, be very careful and use a multimeter. Okay, I'm going to go into a couple technique basics with soldering here. So first off, we have both through-hole and SMD parts. A large majority of our parts are going to be SMD, but we have both, so know how to solder each. So on the left side here, we have the SMD. We will go through this step by step. On the right side, we have through-hole. Basically, with in my personal experience, I think through-hole is a lot easier than SMD, but yeah, you'll have to see for yourself. But basically, through-hole you can see anywhere. It's basically you just have a hole and you apply solder to the hole and you just melt it, and then it kind of just does its own thing and it'll automatically connect the parts. With SMD, you have to be, with certain components, you have to be a little bit tricky with these surface mounts because they're so small and they're so finicky that you're likely going to need to use tweezers to hold down the part. And then you're going to have to apply solder, and well, we'll get into it. But basically, these parts are all going to be very small, apart from the through-hole ones, which are fairly big, because I think the only through-hole parts we have are headers or connectors, which are, you know, like you can hold them with your hands, basically. They're not that bad. But a lot of our SMD parts are going to be slow, so don't rush it. Please work slow. If you mess something up, just undo it. It might be a little bit tedious trying to get into the rhythm at first, but once you get into the rhythm, it'll be a lot easier. But yeah, just to reiterate, please go watch YouTube. I watched a lot of YouTube when I did it, and I'm sure Alexi did as well. Okay, so here's just an example of how to start your soldering. So here in the center of the screen, there is a switch, basically, right? That is our 4 pads for a switch. And what this person is doing here is what we call tinning the pad. Basically, you just apply a little bit of solder to one of the pads, just one, not all 4. And the point of this is to prep the pad so that later on you can kind of like think of the solder as glue here, and you can just stick on the switch on top of there. And you don't need all 4 to be glued, right? You just need one of them and it'll stay still. So basically that's what this person is doing. So you bring the solder close to the pad, and then you touch the solder with the actual heating device, whether it's a heat gun or whatever you're using. And then you touch both of them to the pad, and then it'll automatically basically slide onto the pad, the melted part. Okay, so after you tint the pad, so you can see this person's using tweezers. You hold the part above it, and then once again, you hold your solder pen and you melt the solder, and you press down the switch onto the solder that is being melted. So this basically melts your gluey substance, and then it'll help stick one pin to that pad. And again, you only need one because it's a pretty stable connection, so you won't need all 4. Okay, after that, that's pretty much the hard part. The remaining part is pretty fun and pretty fast too. You just apply solder to the other 3 pads, and you can see this person doing it here. Yeah, so, well, I guess he only does one, but the idea is you just do that with all the other 3. Okay, so this left figure is actually going to happen a lot because it definitely happened a lot to me. Make sure you press down on both sides of your component. For instance, this could be an SMD resistor, or this is what they look like for us. And again, it's going to be very small. So when you're kind of trying to move it around, it'll slide around and sometimes it won't do what you want to do. But just make sure to be patient with it. But if it does end up tilting up like this, all you have to do is melt the left side, right? Melt the solder on the left side, and then push down the right side, and it should fix itself. But in this case, you can see the person used, they put solder on the left pad and the right pad already. So it's going to be a lot harder because you kind of have to melt both sides, if that makes sense. There's ways to do it. You can desolder one end if you want to and then redo it, but it's not too big of a problem. Just make sure that when you're checking for your connections, making sure it's a strong connection, it should look like the top right. And then you apply the solder to the right. So yeah, just do it one pad at a time. Okay, so this is going to be some advice from us to you guys that you might not find in YouTube videos, but again, YouTube videos have a lot more information than we can cover here. So first off is solder flux. We should have some in the lab. If you brought your own, then that's great. But yeah, as it says on the slide, it preps surfaces for better connections. That's really all I can say. It's really vague in how it works, but basically it just helps almost every situation if you're ever in like a really bad situation. So like if you're made of a mess of solder or something, first off, you should try and desolder. If you can't, then apply some flux. This shouldn't be your like first option. This should be kind of your fallback, because a lot of times it's not necessary. Yeah. So my general tip is if the solder is annoying, use flux, because a lot of times it'll help. Okay, bridges are gonna form a lot with us because our MCUs and our voltage regulators are actually very, very small. So it's completely common, no worries about it. And what bridges are for is if you see on this left image here, at the top left, there are two pins that look like they're connected, and that's because they are. There's a solder bridge above them. So basically the solder has formed into a blob, and because there's so much, it doesn't only stick to the pads, it kind of reaches up on the pins and connects to each other. So in this case, the top left two pins are shorted, which obviously we don't want. So how do we get rid of it? Well, we just use a wick. So in general terms, how you use a wick is you put the wick here and you push really hard down on the wick to heat it up as much as possible. So basically you put the wick on top of the solder that you want to extract. And once it's heated up, it'll melt the solder underneath it. So you push down hard on it and then it'll melt the solder underneath and the solder will automatically suck up into the wick. You'll definitely know when it happens because the wick will go from copper a color to like a silver color because the solder is getting sucked in. And then afterwards, you can just lift it up and you'll see that the bridge hopefully is gone. Yeah, this is actually going to be probably the biggest problem that you guys have because the MCU pins are so incredibly small. So I'll say this later too, but basically always start with the MCU. The first step of your soldering should always be the MCU. Don't start with small easy components. You could do one just like test your ability and make sure you know what you're doing. But the hardest thing should be done first, because if you have to redo the MCU, it might screw up the connections around it. So you can see this person pretty much did the same thing. But yeah, the solder wick is going to be your best friend when it comes to bridging. Oh, and again, watch YouTube videos, both on how to use a wick and how to solder an MCU, because there's actually great YouTube videos showing how people actually get these pins done because they're so small. Okay, so heat guns and solder paste. We do have heat guns available and solder paste available, so you can definitely use those if you want to. Again, search up a tutorial before doing it, but basically how it works is you apply paste and you see it's all over the pads here. It doesn't actually matter if it's isolated to each pad because it's bridging over on purpose, because this is basically some kind of, it's a pretty thick liquid substance and there is solder inside it. So when you touch your solder tip to any of these blobs of solder paste here, or use your heat gun, but heat gun is, you can think of it like a hair dryer, but it's a lot hotter. So you apply, like you heat up this liquidy substance here and it'll turn into solder. So you can kind of see this transition from left to middle to right, where the solder paste is slowly turning into solder. And it kind of works magically because it automatically sticks to the pads that you want it to, or everything that it's covering at least. So step one is you apply the paste over whatever pads you want to have soldered. Step two is you place a component on top of it and make sure you push down a little bit. And then step three, you apply heat. So heat gun works. Actually, I would recommend heat gun, but yeah. Okay, so with your boards, the most important thing is to not make any connections that you don't want happening. So basically, if you short your VCC and ground, you're screwed. So make sure you test for continuity before ever connecting your battery. This important notice here is that your battery connector has two terminals and it has a polarity that it's supposed to be in. There's a VCC and a ground. It's going to be very easy to accidentally connect it the other way. So in order to not do that, there should be labels on your board, but if not, make sure you have your PCB design open while you're soldering. So, well, actually, it doesn't need to happen while you're soldering, but basically know which pad is which. So know which one's ground, which one's VCC, and connect the respective ones. But when I soldered, I had the PCB design open the entire time because it would help like, oh, I need a 100 nanofarad capacitor on these two pads because either the text was too small on the actual PCB or it just wasn't showing up. But basically, the PCB design is very, very helpful. Another note, LEDs have polarity as well. LEDs, okay, sorry, LEDs have polarity as well. So if you connect them in the wrong direction, they won't work. And you'll definitely, well, you'll probably run into that problem because I did as well. You could search up to see which polarity it is, but usually there's an arrow. If not, search it up, or you can just test both ways and see which one's right. It's not too hard to desolder and resolder that. Okay, a couple other tips. First off, and the biggest thing is work incrementally. You should definitely start with the hardest stuff. So that's going to be the MCU and the VRM. The reason these are hard is because both of them have very small pins, and the voltage regulator has a very has a hidden pad underneath, which is it's going to be very weird, and you're going to be confused how to solder it. You could use solder paste and a heat gun, but there's also other methods to do it. So make sure you search it up. I won't go too in depth here because it's so specific, but there's a pad underneath there that you need to connect as well. So basically that kind of makes it more difficult. And the pins are very strong. Again, go search it up on YouTube, watch a tutorial on how to solder these super small ICs. And then I say here, save through hole parts for last. You don't need to, but oh, actually you should. Yeah, sorry. I forget why I put it there, but I put it there because the through hole parts are a lot of times are plastic, so they're not going to resist as high of a temperature. So if you put them on before, and then you're applying a lot of heat to the areas around it, they might accidentally melt. So yeah. Okay, again, check your work using a multimeter. This is just hardware debugging. Continuity test is going to be your best friend. And that's just to test for shorts. And be certain of everything before connecting your battery. So that includes testing for resistance, testing for continuity, making sure your voltage regulator is connected properly. Like once you connect your battery, if something bad happens, you're going to either have to start all over or you're not going to be able to. So if you're concerned about anything, make sure you ask us and we can take a look at it before just to make sure. Okay, and then finally, desolder if anything messes up. Don't be at all afraid to restart because it's such a small piece. Like you're probably going to have to desolder your MCU at one point or another unless you're perfect. But I definitely did, and it was a pain. But you kind of learn and you learn and you progress and you get better and better. Yeah, and our lab has more soldering tips. Please read those as well. There might be some reiterated ones, but those are very important, and watch YouTube. Okay, after actually soldering your PCB. So in the lab, make sure you read it. It states that you're not going to solder everything at one time. You're going to solder some stuff. You're going to make sure it works. So for instance, your voltage regulator, we want to make sure that it's outputting 3.3 because that's the most important power signal. So make sure that it's outputting 3.3 and then you continue. So to verify, basically, you're going to connect your battery after you solder a couple things, including the voltage regulator, and then you're going to make sure with the multimeter that it's outputting 3.3 volts. But after soldering everything else, so similar to our Nucleos where we're programming with this board, right? We're basically going to use our Nucleos as a medium to connect to our computers. Okay, so we have two circles here. One is blue and one is red. And this is more detailed in the lab, but basically, there are jumpers circled in the red. It's kind of hard to see here, but you see that there's two horizontal jumpers. They don't really look like jumpers because they're not what we expect to be, but these horizontal two like rectangles, they connect to pins. So when you have them vertical, they connect the 4 pins to 2 and 2. But if you have them horizontal, basically they're just connected to nothing. The pins are connected to nothing. So first step is disconnect those headers. You could also take them completely off, but I would definitely suggest you not do that because it's very easy to lose. If you do, please put it in your box or save it somewhere, but we need those back. Okay, and then the pins in blue, that is what's actually going to be connected to our PCB. So our PCB has a couple of throw-hole parts, but the main one is going to be the programmer that's going to be connecting to this Nucleo. The programmer has, I think, 4 pins. Basically, you're going to be connecting the programmer to this. You can see that there's 6 pins here. You can ignore pin 6, and I think you can also ignore pin 1 because they're both operating at 3.3. So ignore pin 1, ignore pin 6, connect 2, 3, 4, 5. In which order you might ask? Just make sure that each pin is connected to their relative corresponding pin. So basically SWCLK on the Nucleo should be connected to SWCLK on the PCB, pretty self-explanatory. And this is more in-depth in the lab. Okay, in order to make a new project, it's almost the same exact thing in CubeIDE as you did. So you can go back and look at that tutorial if you want to on how to make a project. But in this case, you're not going to use the, sorry, I forget what it's called, the development board package. So before you were using the development board page to make a new project for your Nucleo. In this case, since we don't have a development board, we're trying to program our actual MCU by itself. You're going to go down the list of MCUs and pick out ours. So it's the F4 something RE, and then you'll go look it up in. Yeah, same exact setup though. Make sure you click the right setup buttons, and yeah, go through the previous code as well. Or sorry, not the previous code, the previous guide. Okay, so basically what you guys have to do, first off, get experience with soldering, whether that's asking us or other officers, or going to the IEEE workshop, which I'm not sure when it is, but it should be in the next couple weeks, or watching YouTube. Watching YouTube is definitely my preference, and it's probably the best for some of you guys as well. But before you go into the lab to solder, watch a YouTube tutorial, get caught up. Okay, our lab is going to be called Assembly in the Lab, Assembly in the Quad. Basically, this is going to be due in a couple weeks, and it's split up into different parts. Again, this is to promote working incrementally. And we don't want you to solder everything at once. We want you to solder the VRM, test that it's outputting 3.3 volts, and then you're allowed to move forward. Okay, yeah, like I said, work incrementally, have your PCB designs open. Parts will be in your respective boxes, with exceptions. In case you guys are keeping your boxes, then we'll reach out to you and we'll put your parts somewhere else. But please ask questions, and if you're uncertain about anything, don't blow up your board. Ask us or other officers. Comment during our lab hours if you want more help. But yeah, that's everything. Okay, thank you guys. If you have any questions, feel free to ask us. Hi everyone. So this is kind of just a supplemental thing on how to use cut tape. This is what cut tape is. It's basically cut tape pieces. Pretty much everything that we have is ordered in cut tape. The microcontrollers are a little bit different, but yeah, basically this is what it is. You'll find this in the lab, and our parts, I think in the lecture I say some information that I had fully organized parts, but we realized that most of you guys have taken out your team boxes. So we're basically just gonna put all the parts into a big box. It'll be on our AP shelf, which is to the right of the lab when you walk in. It'll be a big cardboard box. We'll label with AP parts or whatever. But basically all your PCBs and your parts are going to be in there. So first off, find your PCB bag. You can take that wherever you want, but make sure, I think there's like four PCBs, copies of each design that you guys have. So basically you'll get 4 chances to try, I guess. It shouldn't take 4. It should only really take 1, unless you completely burn the board, but those spares are just there in case. Okay, basically there's gonna be a lot of bags with parts like this inside. So this is a cut tape. This is basically a collection of a lot of parts. And you'll see here that there's holes here, the circles, and then above the circles to the right or to the left, there are parts. So each one of those is a component, and they're really, really small, as you can tell by the scaling to my face and my fingers. But like, this is 0603 packaging. These are what most of our passives are going to be. For instance, this is a 20 ohm resistor, or a strip of 20 ohm resistors. Now, you guys won't need all of these, obviously. This is the parts for every team that we have, so make sure to only take however many you need, okay? But you can see the little rectangles. Those are the parts that you will need. The 20 ohm resistors, I think you need 4. I might be wrong, but basically you're going to take 4 out of the strip. Now, how do you do that? It's hard to see on camera, but in real life, you can see that there's kind of this glimmering layer of plastic that's keeping these resistors inside the grooves. So what you're going to do is you can just take your nail or your finger, or if someone else already started, because this is brand new, you peel back the layer of plastic above it. Okay, so I'm not going to do it here because I don't really want to open it. Basically, you peel it like that, and then you peel it back, and that'll reveal the resistors inside their grooves. Be very careful because they will fall out because they're very small and easy to move. So any vibration is going to have them possibly drop out. So yeah, be careful about those. Sorry for the vibrator. Okay. And again, only peel it back however much you need. For instance, if you need 4, don't peel it back more than down here, right? You see there's 4 holes here. Those 4 are each of the resistors. So peel back until 4 resistors are exposed. You can dump them out, keep them somewhere safe, or you can just do it one by one. I feel like one by one is actually better. So yeah, I would suggest do one by one, take it out, put it somewhere safe. I think in your hand is a little bit risky. You can try just leaving it in your box and then transporting it like that, or you can just take the whole tape over to the soldering station and do it there because they're very small. Do not lose these. We don't have that many spares.